Once we have the definition of the dipole in terms of the potentials, we can use the potentials to define the fields. And here we have the differential of the vector potential with respect to time. That's partially partial t. We use that to define E dTA, which is how we refer to partially partial t. Then we can take the gradient of the scalar potential, phi, with respect to time, and that gives us a function we call grad phi. This allows us to derive the portion of the E field that is due to the gradient of the scalar potential, just as we can use the time derivative of the vector potential to get a portion of the E field from the dipole. These two terms together, partially partial t and grad phi, taken together, form the portion of the E field that is called non-motional. In other words, there are no moving detector charges that are used to detect this. You can have a static detector charge that's not moving. Then we get the magnetic field. The magnetic field is in terms of the curl of the vector potential as usual. In this particular case, we have a test charge that we're moving through that magnetic field. It's got a velocity vector that's defined here. We go ahead and express that in terms of EVB, in other words, the portion of the electric field that is the interaction between the velocity of a test charge and the B field. Likewise, we can take the dot product of the velocity and the vector potential, and then take the gradient of that to give us the vector potential gradient term that is used for communication using modulation of the vector potential. And we're going to call that E, in other words, the portion of the E field that's resulting from the interaction of a test charge at velocity v with A. In this case, it's the gradient of the dot product between that velocity and A. And given the gradient, you've then got a potential that can, or rather a field that can interact with the test charge. Those two terms, both of which involve velocity, then form the portion of the E field that's motional, E motional. The detected field, the ultimate field that's detected, is a combination of the non-motional and the motional aspects of the E field.